Okay, hello everyone. How are you all doing? So today we have another Codeforces round, and this is a Div2 round, so obviously it will be rated for me. And we have a strange name here, divide by zero. So yeah, maybe we have a lot of runtime errors today. But let's see. It is being organized by some IIT. I'm not really sure about which IIT. So yeah, it is IIT Indore. Okay, great. And we have another 2 minutes to go. So yeah, let's see how this one goes. And also, like, yeah, we're about to hit 5K subscribers on YouTube. Let me just open it quickly. Yeah, so it's around 4.98K right now, and we're about to hit 5K. So yeah, if you haven't subscribed yet, please do consider subscribing, because obviously this channel is free, like you don't have to pay anything to watch, right? And obviously, if you haven't joined the Discord server, I'll again leave the link to it in the description and you can join it. So yeah, and I hope I'm recording. Yeah, fine. And let me quickly check if my Sublime is working fine or not. And it is. Let's print 3. Yeah, it is printing it. And also, like, yeah, I'm pretty close to losing my candidate master. So yeah, if I don't perform well in this round, I will definitely drop to an expert. So the main aim here will be to save that candidate master. And 10 more seconds. So wish me luck, and obviously all the best to anybody who's giving this one. So yeah, let's start. A sequence of n integers is called a permutation if it. Okay, fine. Given two integers n and k, construct a permutation A of numbers from 1 to n which has exactly k peaks. Exactly k peaks. An index I of an array of size n is said to be a peak if. Okay. So I can start making the peaks from the very left, and I can consider the biggest elements to be the peaks, because that should help, because at the end we'll only have the smaller elements remaining and we can put them in the decreasing order. Okay. So first of all, the number of peaks cannot be greater than n by 2. Should it be n by 2? I guess it should be n minus 2 by 2. N minus 2 by 2. Okay, because the first element and the last element are not peaks, and between them, uh, yeah, the ceil value of that can be the number of peaks. If k is greater than n minus 2 plus 1, or rather I should take n minus 1 only, n minus 1 divided by 2, then you print minus 1, else we'll have to construct it, right? So yeah, int max r equals to n, int min l equals to 1. Should I take 1, or yeah, I can take 1. So the first element will be a 1 only. Then what do we do? Okay, so while k is greater than 0, and we can have a set which tells me which are the elements that I've used. Or rather unused. Should it be unused? Yeah, it should be unused. Unused.pb insert unused.insert I, while k is greater than 0, and v1.pb max r. Then we'll do max r minus minus, and then we'll do v1.pb min l, and then we'll do min l plus plus. So if max r is less than min l, then what do we do? Then we do counter equals to 1 break. Okay, and then we also have to subtract from k, and we'll also have to insert into that, right? Unused dot erase max r, unused dot erase min l. Okay, so if counter equals to 1, yeah. One five two. Okay, this is a peak. 1524. This is again a peak. Fine. 162. Fine. 162. Then you have 2345. Okay, let's keep it 2 here. Let's try to see what do we get here. Yeah, seems to be fine. And what about 3? We cannot have 3, right? Or can we have 3? I think we cannot have 3 peaks for 6 because you already removed those. But wait a minute. You have 4 remaining from them, and then you cannot have 4. But you can have but you can have 3 peaks for 7, right? 1726354. Okay, this seems to be fine. I'll quickly check just some trivial cases. And what about 3 comma 1? Yeah, it should have a peak. 1 comma 3 comma 2. Fine. So I'm submitting this one. So there are only 2 pre-tests here, but I guess there are test cases here, so it's fine. We don't have to check anything here. Moving on to problem B. And now I hope problem A was clear. Like, I did not talk much, but I guess it was very trivial, so it would have been clear. A sequence of n non-negative integers is called good if for all I from 1 to n minus 1, the following holds true: a1 and a2 so on up till equals to ai plus 1, and it should be held true for all, right? It should hold true. Should it hold true for all the i's? Yeah, it's written for all the i's. Is called good if for all the i's from 1 to n minus 1 the following condition holds, that if you take the ands in the prefix till I and if you take the ands in the suffix starting from I plus 1, then they should be equal. Fine. You're given an array A of find the number of permutations P of numbers ranging from 1 to n for which the sequence A P1 so on up till Pn is good. Okay. Since this number can be large, output 10 to the power 9 modulo 7. Okay, this seems tough. Okay, it should hold true for everyone, right? Like what they're telling you here is that if you consider the first element itself, like if you have a1 and then you have this whole a2 so on up till a n, yeah, and a, so on up till an, this should be equal, right? They are telling you this as well. And then what do they want? Then they want that this whole thing a1 so on up till a n minus 1 equals to an. I mean the and of all these values. This should also hold. Okay, so like first of all you have to pick a number. Okay, let's say if you pick 3, then if you have all the numbers from 1 to n, leaving 3, their and should be equal to 3, right? Okay. So using that, I can fix my first number, first of all. Like if I take my first number, okay, let me think about this one. Okay, what are these values? Oh, okay. They've already given us these values. It is not a permutation, like the numbers are not from 1 to n. They've already given us the permutation. I mean all the elements of the array here. Then what do they want? Okay, then they want us to arrange these elements in a permutation. Okay. So then you should have something like this. A1 should be equal to the ands of all the values, that is A2 so on up till AN, right? And I can iterate on the values of A1 here, that if I consider this A1, what will be the and of the remaining elements, and is there a way to calculate this? I don't think there is a way to calculate this. Oh, okay. So first of all, like this is very important here. If you consider these elements a1 so on up till ak, and then you start from ak plus 1 so on up till an, then you know that the ands of these two are equal, right? Like the and of this whole segment equals to the and of this whole segment, right? And then the great thing here is that if you take the and of all these elements, then that will also be equal to a, right? Okay. So you need to construct a permutation such that oh, that is great. Okay, you need to construct a permutation such that every prefix, the and of every prefix should be equal to a, and the and of this suffix should also be equal to a. Okay, so first of all, I'll have to figure out the values here. Okay. So the first element has to be equal to that element, right? Every prefix is and should be equal to the and of the whole array, first of all. If equals to 0, then we have val equals to arr at I. Otherwise we have val equals to val and arr at I. And let's try to print this val first of all. So a great thing here is that the first element of the array should be equal to this val. The last element of the array should be equal to this val. Okay. Why am I getting 0 at every point? Okay. One, okay. The first element has to be equal to this, the last element has to be equal to this. Okay. Then I want a number that keeps the and same, right? Okay. So then I want a number that keeps the and same. So any bit that is set in this number should be set in that number as well. Right. And the other bits I can obviously ignore them. Okay. So I think the answer should be n minus 2 factorial. Like all those elements should have that property. That is the thing. So the thing is that the OR should be the same. No, not the OR. So we have A1, we have fixed a1 and an, and now we want to, let's say, pick a2. So what do we want? We want a1 and a2 should be equal to a2, right? Equal to a1. So what do we want here? The bits that are set in a1 should be set in a2. Okay, the and should be same, right? So m1 dot find val equals to 0. This should have been AR at I. If this equals to 0 equals to m1 dot n, then we print 0, right? Or m1 at val is less than. And are they also giving us an array of one integer? One? No, they're not giving us that. So if it is less than 2, then also you print 0. Oh, why did I do this? Fine. Otherwise, what you do base equals to base into mod phase m1 at val, and then you do mod, then you do m1 at val minus base equals to mod mul base m1 at val mod, and then you need to check that the AND with every other element should be equal to this only. If val and ARRI is not equal to val, then what you do, then you can maybe have a counter. Okay, great. Continue. Fine. Otherwise, what you do? Otherwise, you print cout mod mul fact at n minus 2 base and mod, and I'll have to calculate this fact. What is the limit? The limit is 2 into 10 to the power. Okay. 2 into 1 5 plus, let's say, 10. Fact at 0 equals to 1. So let's see out in line. Fact at, yeah, this should be fact. 6 0 36 and 4, and I hope I'm doing everything fine. So I'll submit it now. Okay, there was a lot of suspense here. So yeah, this problem is done. And why am I not visible here? Okay, I am. So moving on to problem C now. And B was like really interesting because the idea here was that the and value of those prefixes and those suffixes should be, if they're same, then the whole thing is same, right? Okay. So you given an integer n, you have to apply m operations to it. In a single operation, you must replace every digit d of the number with the decimal representation of d plus 1. In single operation, you must replace every digit d of the number and replace it with the... Oh, okay. So 9 became 1, 0. Fine. You have to find the length of n after applying m operations. And m is not very large here. So if I can just store the number of ones, zeros, and everything, like, I think this should suffice then. Okay. Because every time you have a 9, then you sort of increase your 1 by 1, and then you increase your 0 by 1. Let's keep it LL only. And here I'm storing the occurrence of each, each digit here. So it should be 10, because 0, 1, 2, 3, so on up till 9, yeah. And we have 0 initially. While n is greater than 0, then you do awk at n modulo 10 and divided by equals to 10. And maybe we can debug our occurrence here. Okay. Occurrence at 9. And occurrence at 1. 1 will increase, right? Okay, let's do mod mul only here, because I don't want to get into that. Why am I getting 40320? Maybe I should debug my awk at every point. let's consider the first one only because we have a wrong answer in the first case itself. So here it was awk1 at I equals to awk1 at I minus 1. Why didn't I have this here? Awk9 should have been mod add. Oh, it should have been mod add. Okay, seems to be working fine, and I'll quickly submit it. So I guess C was easier than B here. Not really sure because yeah, right now the pre-tests have not passed. Maybe there was something else I had to consider. Time limit exceeded. Why exactly will I have time limit exceeded? M is less than. Oh my god. Oh my god. It did not say that the sum of all the m's are till 1e5 because every m can be up to 1e5. So yeah, then I'll have to figure out. Okay, I read the problem wrong here. My mistake. Okay, let me walk around and think about this. Okay, so I think I'll have to pre-compute this part. I'll have to sort of do a DP here. So DP of 10 comma n max. I shouldn't have made that wrong summation here. And what is the range of m here? The range is dp at j plus 1, and then you have I minus 1, and dp at 9 comma I equals to dp of 0 comma I minus 1 plus dp of, I should do a mod here, mod add instead. I did not get any output here. Maybe there is something wrong. Okay, now it seems to be fine. So here now it is like we've already pre-computed everything. Yeah, okay, fine. I should have read the problem carefully because it amounted to an unnecessary wrong submission, and yeah, it took a lot of time then. So no issues still. It was fine.